Hey, hi everyone. Welcome to my YouTube channel. My name is Sunny Savita, and in this video, we'll discuss about this rank fusion. So, guys, I was working on this retrieval site. This retrieval actually it's a very important part of the rank pipeline, and there are so many things, so many concepts related to this retrieval. So, while we are retrieving the topic, so we can retrieve the topic based on the different methods, and after retrieving, we can re-rank also. Okay, so this retrieval document is called the rank document, and again we can re-rank it. Means like we can perform one more retrieval on top of the rank document, and that is called the second stage retrieval. Okay, and that is also called re-ranking. So inside this re-ranking chapter, I discuss about the sentence transformer, BM25, cross encoder, cohere API, merger retriever, or long context reorder, where I discuss about this lost in middle phenomena. Now we'll discuss this rank fusion. What is this rank fusion? And after this rank fusion, I will discuss about this flash rank. Okay, this is one of the one of the module inside the langchain itself, one of the class basically, and the entire code is also available related to this flash rank. I will be talking about it in my upcoming video. Now, first of all, let me show you my YouTube channel, and let me show you that what all thing actually I have covered so far. So, related to this retrieval and all, guys, I have created one separate series. So the series name is what? The series name is Advanced Rag. Okay. So so far I recorded 5 video inside this particular series. This is sixth video. Now apart from this, I'm thinking about couple of more video. So in those video, I will discuss about the different retrieval. We have self query retrieval. Okay, we have sentence window retrieval, small to big retrieval, that is called parent retrieval, right? Or compressor retriever, contextual compressor retrieval. There are so many retrieval which is available. So definitely we're gonna discuss inside this advanced reg series. And yes, you will find out around 4 to 5 more videos with respect to this one. If you want to start, really, if you want to start from the retrieval, you can start from here, from this particular session. There I have talk about hybrid search, how you can perform the hybrid search like keyword search and the vector search, which is a very important part of the retrieval. At many places, actually, you will find out for making a robust pipeline, people are using this technique. Okay, now let's come to the agenda. So today I'm going to discuss about this rank fusion. Now, what is this rank fusion? Now, along with this rank fusion, one more topic is associated, that is called reciprocal rank. Okay, reciprocal rank fusion. So I will talk about this reciprocal rank fusion as well. This is looking like a very heavy thing, but it is not, guys. If you are familiar with the basic rack pipeline, easily you can understand these topics and all, and easily you can implement it also. See, my solution is ready. Here you can see my solution of the rank fusion. And apart from this one, guys, I'm working on the very amazing thing, and soon you will get it. Okay, soon I will be uploading this video as well, like basic rack flow, self query retrieval, and apart from this one, see, many more topics, many more like retrieval types I have kept, and I'm already working on it. See, retrieval with the hypothetical answer document, hide, which is called hide, right? And yes, so if you haven't subscribed the channel, please do subscribe. It's a request to all of you, because see, guys, this AI is going to be a very important part, okay, of the software development of this IT industry. And this is just the starting of the AI. And in the upcoming days, in the upcoming year, you will find out the advancement. Okay, you will find out the huge advancement in this AI field, and the story begins from here itself. If you want to build something using this AI, using this AI concept, if you want to become a successful AI engineer, definitely you should learn this concept. And you can learn this concept where? On my YouTube channel. And please subscribe, please hit the like button, please share with your friends, with your peers, whoever is trying to learn this generative AI, this AI. Because yeah, it's a future, and definitely we should invest the time on top of this AI and all. And don't worry, soon I will be starting my Hindi channel as well. So there also I will be uploading my content over my Hindi channel, and many more things, not only this generative AI and generative AI and this like a concept like RAG fine tuning, the core concept as well. Okay, core concept like machine learning, deep learning, like a few concepts related to the analytics. Okay, the a few concepts related to the ML ops and LLM ops. Everything you will find out over here, so that you can become one robust uh, AI engineer, one successful AI engineer from learning here, from learning my YouTube channel. So let's do one thing. Let's try to understand the concept of the rank fusion. But before coming to the rank fusion, let me revise the architecture of the RAG. So this is the architecture of the RAG, and here guys see. Uh, so guys, this architecture, this RAG architecture is a very dynamic architecture, and we can make a changes inside this architecture at each and every stage, right? So majorly we divide this architecture into three main parts. So the first part or the first stage is called the data ingestion from here to here. The second stage of this architecture that is called the retrieval from here to here, this one. And the third stage is called the generation from here to here. Got it? Now see guys, uh, why it is dynamic. So let's say we are collecting a data. So first of all, this data could be anything. It could be in any format. Okay, unstructured structure, in a structure CSV, TSV, Excel and all. In a semi-structured JSON, XML, HTML, or in unstructured text, video or voice data, right? It could be anything. So after collecting a data, we always have to divide into the chunks. Now here guys see, this chunks also plays a very important role inside this architecture, okay, inside this pipeline. If we are not deciding the optimal chunk size inside, in that case I can get the error, okay, I cannot get the good result. So this chunking also plays a very important role, and definitely I will upload the video related to this chunking and all, how you can decide the optimal chunk size. Then this embedding actually it's having, there are so many hundreds of model of the embedding, and there are so many model, right? The model related to the higher dimension, lower dimension, okay. uh, so upper higher dimension like more than 1024 and all. You'll find out each and every type of model of the embedding, and many of them I already cover on my YouTube channel. So now this is all about the data ingestion, and see, mainly the main component of the data ingestion is what? This database, where actually we are storing a data. And in my previous, in my videos, if you will go and check with the videos, right? So already I had discussed so many database and all, like Neo4j, MongoDB, Web8, Pinecone, every database I try to discuss, and even I showed you the comparison as well. So here is a like list of the vector database. Here is a comparison of the vector database based on the different factors. Definitely you should check it out if you want to become a robust RAG pipeline, right? So this thing is clear now. See, so the second part is called the retrieval part. Now what is my topic? What I'm going to discuss here, I'm going to discuss RAG fusion. So this RAG fusion I can divide into two parts. First part of this RAG fusion is called the retrieval, okay, retrieval. And the second is called reciprocal rank fusion. Reciprocal rank fusion. Here we use a specific formula, and using this formula, what I can do, I can re-rank my result. This particular stage is called ranking, and here this is called, the second one is called re-ranking, and combinedly I can say it's a two-stage retrieval. What is this stuff? It is called two-stage retrieval. Got it? Now where it lies. So first retrieval, first rank result. So I can take my result from here. Okay. I can perform the semantic search based on my query, and I can retrieve the result. And this is called my rank result. Now after the rank result, what I can do, I can use the formula of the reciprocal rank. Okay. I can use the formula of the reciprocal rank, and then I can perform the fusion. I will let you know what is the meaning of the fusion. So in simple term, if I can explain you this fusion, that is nothing, that's a melting. Okay, melting or combining the multiple things. Okay, combining. So that's the meaning of the fusion, and definitely we're going to discuss over here. So let's look into the architecture of this RAG fusion, how it looks like, and where it comes, guys. Tell me, it comes inside this retrieval, means from here to here, and then second one is what? Second one is a re-ranking. After collecting the rank result, again we can re-rank it. So this is the architecture of the rank fusion. Let's try to understand it. As I was telling to you that we have a user query. Now this user query I can pass to my LLM. Okay, I can pass to my LLM and I can generate the multiple queries, right? Let's say I have generated four query. First query, second query, third query, fourth query, and this is my original query. Original query. And here is what? Here is my hypothetical query. Now this query, this 1 2 3 4 5, the 1 2 3 4, this particular query I'm passing to my database. Okay, my DB. And what I'm doing, can anyone tell me? So here I'm performing similarity search. I'm performing similarity search, and this query as well, this original query also. If I can explain you by this architecture, so just look over here. So my user is asking the question. So this question is going through the LLM here, LLM, and I'm passing the prompt to my LLM. I'm saying, okay, generate four hypothetical query from this particular query. Let's say my question is, who is Sunny? Okay, so around to this question you can ask multiple question. uh, who is Sunny means what Sunny is doing. Okay, Sunny is a living entity or the non-living entity. Where Sunny is living, right? What Sunny is doing. So multiple question related to the one single question. Okay, I will design my prompt in such a way it will automatically give it to me. So this question I'm again passing to my database, and based on that I'm getting the retrieval result. Retrieve result means the rank result. And the original query also I'm passing in the same way. Getting my point? And all the thing actually I'm going to combine after when? Tell me. After re-ranking. Re-ranking using what? Re-ranking using this reciprocal formula. I will tell you what is this reciprocal formula. Reciprocal formula. And finally I will combine all the thing. Finally I will melt. I will combine all the thing. That is called the fusion. I hope you are getting. So I'm passing to my database. Here I'm getting my vector search means my retrieve result, and then I'm passing it to my reciprocal rank. And here I'm re-ranking. So this reciprocal rank is responsible for the re-ranking, and then finally I'm generating my output using my LLM. This third stage. Okay, this generation is stage. I hope this architecture is clear. If not, I will take one more example, and with that I will try to explain you. So this is the theoretical stuff, theoretical point which I written just to explain you. So for first, what I have to do, I have to generate a query, okay, using the LLM from my original query itself. Then I'm performing a vector search, okay, on top of the newly generated query and the original query. Then I'm aggregating and re-refining all the output using what? Using this reciprocal rank fusion. And then finally what I'm doing, I'm passing this re-rank output to my large language model for generating the final result. That's it. Now what is this reciprocal rank fusion? So this reciprocal rank fusion is a technique which for combining the rank of multiple search result. Okay, so multiple search result to a unified result. Okay, so I am getting one unified result from the multiple search result, and it has developed by the Waterloo with the Google itself. So yes, Google is also involved inside this technique, and you will find out the specific research paper of this particular technique. So if you will search about the reciprocal rank fusion, so definitely you will get this particular paper and see here the complete detail and all. So this person was involved is Stephen Butcher from the Google side, and the CLA Clark, GB Core Mac. So these are the person is involved from where? From the Waterloo. Okay, University of Waterloo. Now this is the formula of the reciprocal rank fusion. So in some time I will explain you this particular formula. Getting my point? Now I have my solution as well. Definitely I have already shown you. I will come to that and I will explain you from scratch. So you can check out with this research paper. You will get more detail. But yes, whatever thing is required, I will let you know inside this session. So now guys, let's try to discuss that how this reciprocal re-ranking is working, how this rank fusion and this reciprocal re-ranking is working. So let me explain you it. Let's say here is my query. So I can explain you over here itself. Query. Now what I'm doing, I'm generating a multiple query from this particular query. So let's say I have generated three queries. Okay, I'm just taking an example. You can take three, four, five, and all, anything. It's up to you. I'm not uh interfering in that. Okay. So how many queries I'm generating? I'm generating a three queries from this query. So let's say here's my query one. Query one. Here's my query two. Query two. And this is my query three. Right. Now this query will go to the database. So let's say here is my database. Okay, this one is what? This is my database. Same database. Okay, same database. Now this is my database. You can create a multiple database. You can create the multiple retriever inside the single database. It's up to you, like how you are designing your architecture. I'm not going to interfere in that. So let's say inside my database, I'm having 6 documents. I'm just taking an example. Let's say I'm having a 6 document. So A, B, C, D, E, F. Getting my point? In total, 6 documents. And this is my DB. Now I'm performing similarity search, right? I'm performing similarity search and I'm collecting my output from here. So let's say here is my similarity search. Similarity search. This one. Here also I am having similarity search. Okay. And here is what? Here's my output. Similarity search. Here is what? Here's my output. Now, what output I collect? I collected over here. Tell me. Let's say I got this A, C, D, and B. Okay, this is my rank result. Here is what? Here is my rank result. This one. Now here I got, let's say, B, A, C, D. Okay, and this query 3 actually, this is the query 3, and it is more relevant to this D. Okay, B, D, B, A, and C. What is the meaning of it? So this query 1 actually it is more related to this document A. This query 2 actually it is highest related to this document B. This query 3 is highest related to this document D. Okay, E and F is not there, means it is not related to any of the query. Got it? Now what I will do, I will perform the reciprocal rank over here. So first of all, I need to calculate the rank of this particular document. How I can calculate? Let me tell you. So first I will calculate the rank. Let's say uh, I'm going to collect a rank of this A, C, D, and B. So what is the formula of this rank? So here is the rank. This is at the first place, rank 1, rank 2, rank 3, rank 4. Okay. B, rank 1, rank 2, rank 3, rank 4. Now I can give the number as well, rank 1, rank 2, rank 3, and rank 4. Now I am performing what? Reciprocal rank over here. Reciprocal rank. So reciprocal means what? Reciprocal means the reverse of it. Okay, reverse of the rank. So I can simply write over here, reciprocal rank is nothing, 1 by rank. Okay, so here I am getting what is the rank of this A? Tell me, guys. So here the rank of A is nothing, 1 by 1. Okay, what is the rank of C? 1 by 2. Here the rank of D, 1 by 3, and the rank of B is 1 by 4. So this is the reciprocal rank of A, C, D, and B. Likewise I can calculate for this one also. So for B, what is the rank, guys? Tell me. So here for B actually 1 by 1. For A 1 by 2. Okay. Now for C 1 by 3, and for D 1 by 4. So here is the rank of what? B, A, C, and D. Now I can calculate for this also. So let's say for D, what is the rank? 1 by 1. For B 1 by 2. For A 1 by 3. For C 1 by 4. So I can simply note it A, D, B, A, and C. I hope it is clear. Now see. So what I will do, now I will calculate. I will fuse it. So now my next stage is what? The fusion of the rank. So here I have to fuse all the rank. And this stage actually it is called the fusion. Fusion means what? Combining or melting. So here actually I have to do summation of all the A. Okay. Summation of B, then summation of C, and summation of D. Summation means adding all the rank. So here I'm going to be add all the A. So 1 plus 1 by 2. 1 by 1 means 1 only. 1 by 2, and here 1 by 3. By 3, this is for A. Now let me write for B also. So for B, 1 by 4 plus here B is 1. Then here is B. It is coming in the second place, 1 by 2. Now for the C, I am going to be calculate for the C also. So 1 by 2 plus here C 1 by 3, and here C is coming at fourth place, 1 by 4. Now for the D, so D is coming at 1 by 3, 1 by 4 plus 1. So this is the result. Okay, result for A, B, and C. Now if you are going to add, you will be getting the value. So what is the value, guys? Tell me. So for the A, guys, 1 plus 0.5 plus 0.33. Now here 0.25, 1 by 4 is 0.5, 1 and 0.5. Now 0.5, 0.33 and 0.25. You can add on it also. Okay, I will be adding, don't worry. So 1 by 3, 0.3 plus 0.25 plus 1. So this is the result. Now what I can do, I can calculate it also. So 1.5, so let me calculate it over here. 1.05, 0.3383, 1.38. So it's going to be 1.38. Now here let's calculate this one. So 1.05, here 0.25, 0 going to be 1.30. So this is going to be 1.3. Okay, now here let's calculate this one. So 0.5, 0.33, 0.50, 8, 0, 1. So it's going to be 1.08, 1.0. Now let's calculate this one. So 0.1, it's going to be same 0. No, not same actually. Calculate 1.0, 0.3 and 0.25. So 8 to 5 and it's going to be 1.5. So this is my answer, guys. Think it is correct or not? 538, 325, 1.58, and it is 58. Yes. So guys, I think is correct. Okay, 0. This is going to be 15038. It is 1.83. Sorry, it's my bad. I hope it is correct. So this is the value of each and every document. Now, if I want to rank this particular document, so how I will do it? So this is the maximum. So A will remain at the first place. Okay, A. Then after the A, guys, what will come? Tell me. After the A, I will be getting what? I will be getting my next document, that is D. Then what I will get? I will get my B. Okay, and then C. So this is my final document which I am passing to my LLM in this particular sequence. I hope you are able to understand this complete approach of the re-ranking using this particular example. So as many as query you can generate, and it is working in a similar way for what? For the uh like for the original query as well. Here I have included the original query now, right? So I hope this reciprocal re-rank is clear. Now let's look into the formula of it. So here, guys, this is the formula. I kept the formula. Let me show you this particular formula. See, guys, here it is. So here is a formula of the reciprocal rank, as you can see. So 1 by rank. Okay, here is the rank RD, and this K actually it is representing to the weight. So this is nothing, it's my weight, right? I can take any sort of a weight value. See, 1 by R is nothing, the same thing which I was telling to you, rank of the document. And I can add on one more value over here, that's a weight value. Just to normalize it, I can see generally it is 1, so it won't affect. Sorry, generally basically we take the 0 only. Okay, so it won't affect. It could be 1, it will be 1 by rank only. But if I want to normalize it, if I want to like suppress the value or suppress this particular value, so I can add on any sort of a value over here. So yes, I will be getting the optimized value over here, which I can regulate by using this weight. This k actually it is nothing, it is representing to the weight only. You can read it inside the research paper. Now let's look into the solution. So here is a complete solution of the rank fusion, guys. Now let's start with it. So first we need to install the libraries. Here is my library, guys. Langchain, Hugging Face, Tick Token, PyPDF, then Google Generative AI, ChromaDB, Sentence Transformer. I'm using Gemini model for implementing this rank fusion. So let's install it and let me show you the result. Apart from this one, we require this langchain as well. Okay, langchain community. So let me install this langchain community as well. Here is my text wrap, guys. Text wrap is nothing, so it is just showing you the data in a specific format over the console. That's it. So if you will pass your data, okay, text, so what it will do, it will divide into the lines, and then what it will do, it will take that particular lines, it will fill it. Okay, it will keep it inside the in the specific format. Okay, whatever length and width actually you are passing. So after this one, it will give you the result. Okay, so just to show you the data in a specific format, I have written this particular method, nothing else. Nothing, there is no such logic. So now what I have to do, so after installing this library, first I'm going to be like configure my Google API key for loading the Gemini model. How you will get this Google Gemini API key? I think in my previous sessions I already shown you. You can go and check out with those particular session. You will get to know about it. Now where I kept this key, so I kept this particular key inside my collab itself. See, this key is available over here, Google API key. Now after configuration of this key, okay, so let it complete, then I will execute it. Now after configuration of this key, what is required? I require this particular module name is langchain Google generative AI. I'm using langchain. I'm not going to implement it from scratch. For that, actually I have to write like many lines of code. In some of the retrieval, definitely I will show you from scratch a couple of concepts, the small concept. I written it from scratch, but not in this one. Uh, I'm using the LangChain over here. So this package is also required. So let me execute this code of line, and this one also here. Let me install it. After installing it, guys, see what I'm doing. I'm getting my model. So which model I'm using here? I'm using Gemini 1.5 Pro. So after loading the model inside this variable name is LLM. So I'm just checking whether everything is working fine or not. I already executed this code. That's why here you can see the answer and all. But don't worry. Again, I will show you. Again, I will run in front of you, so we will get the answer. Now see, after loading the model, I will be getting my answer. Okay, so this is the first phase of this particular practical. Now in the second phase, so what is required if we want to create a rag? So for creating a rag, guys, we require data. And here, guys, I am loading the data from my drive. I kept the data from in my drive, and from there itself I am going to load it. Now inside the data I have a multiple files. I have multiple text files. So first of all, let me introduce to you with the data, and then I am going to be loaded over here. So here, guys, I kept the data in my local as well. So this is my data, and this data actually, see how many files we have. So inside this particular data, in total, I have 646 file. Correct, guys, more than 600 files, and it is all about the Singapore. Yes. So just look over here. It is having a complete detail about the Singapore. These particular files, so you can see a local fashion of the Singapore, okay, guide of the Singapore, a day guide of the Singapore, best restaurant, kid friendly experience of the Singapore, annual food, okay, affordable food, art, science, Asian, every related information of the Singapore. If you will open your file, you will get the data and all. So here let me show you this particular file. So see, guys, here this is the file. Just a second, this one. And look inside this file, and it is having this particular information. So it is giving you the link as well. Just go and check with this link, and after clicking on this link, let me open this it at the browser only. So I am just going to open it in my web browser, and see, guys, it is having a detail of the Singapore and all, Singapore eternity due 2 day in, and some sort of a description and all about it. So this is my data which I am going to take, and this is from the booking.com, and also it is giving the reference as well. And likewise, I am having multiple files, guys. So like I'm taking a file, I'm taking a different type of scenario, so that you can understand how to load it, how to get the data, how to collect the data from the multiple sources, from the multiple file, guys. This is very much important, because in the real time you will be getting this particular data. You are going to deal with this type of situation only. So now let's begin again with a solution. So here, till here, I hope everything is perfect, and see my model is also working fine. Now, my model is also working fine, and here I'm importing other statement, and after this one, I'm importing this directly loader and text loader as well. So now, first of all, let me connect with my drive. So where I will get my drive here, because I kept my data inside the drive. So that's why I'm going to connect with my Google Drive. Once you will click over here, it will give you the option for running this cell. So just run this cell. Automatically, it will provide you the code, and now it is asking to connect your drive. Just select your mail ID, and then click on this continue, and then definitely you can just give me a second, let me give the permission. Okay, just continue, click on the continue, and yes, my drive is mount. So once you will refresh it over here, you will be getting your drive, and from there easily what you can do, easily you can copy the path. See, drive is mounted. Now just refresh it, and here is your drive. Just go through with your drive. Here is your my drive, and inside this drive, this is the data. Now just copy the path of it. So let me copy the path and let me keep it over here. So already I kept it, but just to show you, I'm just like repeating that step. Now I got my data path. After getting the path, guys, this is the code which I'm using for what, for loading this file. So data path, inside this path, this is my file.txt file, and so progress is true, I'll be getting my progress. Let me load the data. Let me load the entire data from the directory, and here it is saying okay, it is asking to me pip install unstructure as well. So let me install this unstructure over here. Just a second. Let's keep it pip install unstructure, and yes, it started. Okay, so my library is installed. After installing this unstructure, I think I can load my data. Let me show you how to load it. So once I will run it, just a second. So once I will run it, I can get my data inside this doc. See, it is progressing, and how many document actually it is processing? 646 document. So after processing it, all the like document and all, I will get it over here and I can check the length and all. I'm not going to use the entire one because it is having a lot of information. And inside this system, inside this configuration, I cannot process this much of data. So I'm just taking 50 document. For that, guys, I require the Collab Pro where the RAM should be high, the disk should be high. Okay. So that's why what I'm doing here, I'm just taking a 50 document, and on top of it I will show you the complete process. So yes, let it complete, let this loading complete, and then we'll start with the further topic. Okay guys, so now successfully I have loaded the data. After loading the data, as I told you that I'm just going to be select only 50 document, so let me take it. So here is my 50 document. I'm just performing a slicing. Okay, so here is the document, right? Length is what, 50, because I already assigned this one. Then here I'm checking with my first document. So let me check with the first one. So this is the content of the first document, page content. And if you want to check the specific content, so here is a content link. Okay, and here is the like the other content. Okay, so this is with respect to the first file. In some file you will find out the lots of content. In some file you just find out the like one or two line. That's it. If you want to check the next one, so let's say if I'm clicking on this, if I'm checking with the first one, so see, title, festival, event, and all this is the other details. Now you can check with the second document also. You can simply write over here too. So here is my second document, and this is the information related to this one. So likewise, yes, you can check the complete detail and all. Now what I'm doing, I'm just combining each and every information here, whatever information is there right inside this document, this one, inside my text, okay, inside my raw text. So I'm taking one empty string, and I'm iterating over the document, and I'm collecting the page content, means I'm just collecting this particular information, and I'm keeping where inside one variable, okay, this one. So inside my raw text actually, I'm combining each and every detail, each and every information of all the 50 document. Now, see, if I will print it, this is my complete information of all the 50 document. I hope it is clear. Now, see. So, guys, after collecting this particular information from the from all the document, I'm performing, I'm chunking it. Okay, I'm converting it to the chunk. This is a chunk size, right? Chunking overlap is 100. So chunk size means what? I'm considering 500 tokens inside the single chunk. Chunk overlap means what? From previous to next chunk, the overlap tokens. So last 100 tokens, okay, till 400, it's going to be overlap. Okay, from previous chunk to, sorry, next chunk to previous chunk. Now here is my length function, so I can pass it, and here is my regular expression. So no, I'm not going to be use any sort of a regular expression over here. Simply I'm using the like this recursive character split. I'm not defining any sort of a logic from my end. Now I'm passing this document, this raw text, to which one? To my text splitter. And after passing it, guys, what I will get? I will get my tokens. Okay. So I will get my sentences, chunks with the 500 tokens. So let me check the length of it. So here in total, I have 262 chunks. 262 chunks, and in one chunks actually I am having 500 tokens. Now let me check with the text 4, means the fifth number of chunks, because it's going to be start from the zero now. So this is my fifth chunk. So this is my like fifth, as you can see over here. I hope till here everything is perfect, everything is fine. Now what I have to do, I have to keep the data inside the database. Inside which database? Inside my vector database. So this is my model, Hugging Face BGE embedding. It's a quite popular model of for the embedding and all. You could check out. So it is available inside this particular repository over the Hugging Face. Now let me sorry, this is the class actually, and this is the model. PGE is small, en v1 b 1.5. Now I'm going to be load this model, and after loading this model, guys, here see what I'm doing. I'm passing my model name. As of now, I'm not running over my GPU because it was not enabled. So I'm like commenting this particular step. But if you are running over the GPU, you can like remove the comment. Then here is my document. Here is my this one argument, and inside the argument, I'm saying this normalization embedding is true. Okay, I'm going to perform the normalization of the embedding. Normalization means what? So the value of the embedded number will between 0 to 1 only. Okay, so whatever numbers will be having inside the embedding, all the numbers will be between 0 to 1 only. So here's my embedding function, or you can say embedding like model, anything you can say. I kept inside this embedding function. So now let me run it, let me execute it, and yes, it is loading my model. Now after loading the model, guys, I'm keeping the entire data where I'm keeping the entire data inside my Chroma DB. And where I'm persisting this directory, I'm persisting this directory inside my local, okay, inside my local workspace. So this is my data text, this is my embedding function, means my Hugging Face model, and here is my persisting directory. So let me execute it. See here my model is loading. Now I can store the data on my local, okay, in my Chroma DB. Now after it, what I will do, guys, so here I'm asking, I'm checking with the similarity search. Okay, so this is my query. So I'm asking, tell me about Universal Studio Singapore. So after like keeping the data, definitely I can run it and I will be getting the similarity search. Let it complete and then I will show you this part. Now see guys, my data ingestion is complete. After ingesting a data, I can perform the similarity search. Okay, I can ask a query to my database. So similarity search, I'm calling to this particular method, and this is my query, and I'm retrieving in total 5 documents. So once I will run it, guys, so here I will be getting my 5 documents, similar document. So this is my original query, this one, and this is the document which I'm retrieving. Okay, from there, it's a rank document. Okay, so first document, this is my first document, this is my second document, here is my third one, fourth one, and fifth one, and see the result of it. Got it? Now I'm setting up the retriever. Here I'm calling this db.as retriever, means I'm using my database as a retriever here. I think you know about it, right? Retriever and all. Now here I will get my retriever, and then I can get my and I can fetch my relevant document on top of it. So let me execute it, and yes, it is working. I can do the I can perform the mmr also. Mmr means what? Maximum matching. Okay, maximum matching relevancy. So here I'm getting the most similar document, but I can what I can do, I can perform the I can write the value of this mmr as well. Okay, means such type is equal to mmr, and what I will get, I will be getting the most relevant document, and I will be getting most nor not relevant document, means the document from the last one. Okay, the last rank I will also get. So that's the meaning of the MMR. I think you can search maximum margin relevancy, something like this. Okay, so that's a full form of MMR. Definitely you can check out. Now here I'm getting this three content. Okay, according to my this one. So according to what? According to my query. Now see, I think it is 4. Maybe by default it is giving the 4. Okay, let me remove it again. Of 1, 2, 3, 4. Okay, let it be 4 itself. So here what I'm getting my code document. I think the parameter, the argument will be different. I'm passing k maybe. That will be a different one. So let's see. This is the 4 document. By default, in every retriever, you will get the 4 only. Now here is my chain for generating the final output and for performing the RAG fusion also. So the first one is prompt template. Second is output parser. Then a renable lambda, and here is what? Renable pass through. Now this is my template. I'm saying answer the question based on only the following context. So I'm passing my context, and based on that I'm going to generate my answer. Okay, so here is my context, and based on that, okay, so here is my context, whatever context will be there, this is my question, and I'll be generating the answer. That's it. Now I'm passing it to my chant prompt template. After passing it, guys, I will be getting my prompt template. So let me execute this part, this one also, and this one. Now here is what? Here is my LLM. I can show you my prompt, so how the prompt looks like. So this is my prompt, guys. Here is my prompt, this one, right? Now there is two things. One is context and the second is question, this one. So I'm will passing context and question. Based on that, my answer will be there. Now, what I'm doing, I'm creating a chain. So here in my chain, guys, see, I'm passing my retrieval. Here is my quotient. Means runnable pass through means at the runtime, okay, parallelly I can pass the quotient. Here is my prompt LLM and output parser. Now this retriever actually where I will get. So this retriever actually I will be getting from this particular retrieval, this context. Okay, I will be getting from this retrieval, this one, this particular information. I'm going to pass this particular information. I'm going to pass over there. Got it? Now let me execute it. Let me create this chain, and here is what? Here is my answer. So if I will ask this, tell me about Universal Studio Singapore. So what I will be getting? I will be getting my answer, and I'm passing to my wrap text. Wrap text actually it is what it is doing. It is giving me a particular answer, the specific answer. See how accurately it is providing to me. If you will look into the other one, na, so definitely you will find out the, if you won't find out the the aligned one. So here you can see the answer and all like in a complete sequence. But see, when I'm passing to the wrap text, it is giving me a very refined and the precise answer. It is just for the formatting of the text, nothing else. For getting the refined answer, actually, we are using the LLM. Now, with the RAG fusion. So this was the simple pipeline. Okay, simple RAG pipeline. Now let's perform the same one using the RAG fusion. Now, couple of line or more we need to understand, and then I will wrap up. So here, guys, here is my output parser, system message prompt, human message prompt, okay, chat message prompt, and prompt template. So these are the module basically I required over here. So after like loading it here, what I'm doing, see guys, now focus. So I'm passing my original query. Okay, I'm passing my system message. I'm defining my system message. I'm saying you are a helpful assistant that generate a multiple search that generate multiple search query based on what? So see, multiple search query based on the single input query. The same thing we are doing over here. Okay, based on my input query, I'm going to generate a multiple query. Now here I'm writing, see, this is my input variable, original query means based on my original query, I'm going to generate a multiple query. How many queries, guys? Tell me. Here I'm going to generate four original query, four like query from the original query. Okay, four hypothetical query from the original query, four hypothetical query using LLM. Uh, okay, four hypothetical query using LLM via this original query, right? I hope now you are getting it. So this is my prompt, guys. Let me read this particular prompt. So let me run it now. And here is my universal query, original query, right? You can write any sort of a query over here. I just written the name. According to that, basically according to this particular name, it is going to be generate a multiple query. How many query? Four queries. Okay. So this is my original query, and this is the chain. First prompt, then LLM, then it's out parser. Okay, output parser. Now whatever answer I will get, I am going to be split it based on this slash n. Means based on the new line, basically I am going to be split this particular answer. Now let me run it. Let me execute it. So here is my generated query, and now I will show you it. So this is the complete chain. Okay. So I hope it is perfect. Now what I'm doing here, see guys. So this is all about the generated query. Please remember generated query. I will combine each and everything at the end. Now this is the code for the reciprocal. So what I will be getting my result list of result. Okay. Now here what I'm doing, I'm going to be iterate on top of it, on top of this particular result, right? This is the iteration. Now after iteration, guys, what I'm doing here, actually I'm going to be calculate the rank. So how I'm calculating a rank, guys? See here, this is the formula for calculating the rank. 1 by rank plus k. Okay, this is the specific formula where actually I'm going to be assigned what? I'm going to be assigned the number. Okay, rank. Okay, the reciprocal rank to my document with the weight value. This is nothing, it's a weight value. And here what I have written, this weight value is 16. You can write anything. You can write 0, 1, 2, 3, 4, 5, anything. Here I have written 16. So 1 by rec plus k. Okay, it is for the normalization, and it will be same. It will be universal for all the document. So yes, we are not going to make a discrimination over here because this value actually is going to be same for every sort of a document. So this is the formula. Definitely you can understand this particular formula, but this is the main part. You can understand this entire logic I written by myself, and definitely like you can execute it. You can run it inside the separate cell, and you can understand this logic. So let me run this reciprocal rank, and now see guys, this is my final chain. So generated query, I'll be generating four query. Then retrieve map, I'm going to be I'm going to be mapped to my retrieval to my database. Then I'm going to perform the reciprocal rank. Okay, and this is my RAG fusion chain. I hope you are getting it. Now let me run it, and here I'm setting this debug is equal to true so that I can get all the information whatever is happening in the backend. Now this is my complete schema, like RAG fusion schema, and here you can see prompt input object quotient and all everything. Now what I will do, I am going to be invoke this chain Rank Fusion check with the original query. So whatever my original query, this one. So this was my original query. With this particular query, I am going to be invoke this chain, and let's see what I will be getting. So just focus over here, guys, and see. Here is my output. Okay, just see. Now look over here, guys. It is running. And first of all, just look into the answer. Here it is generating four more query based on this particular query. Universal Studio Singapore ticket price and discount, best time to visit, Universal Studio right height and requirement, hotels near Universal Studio in Singapore and all. So these are my four query. Now what I will do, I will fetch the result based on this query, right? So let me scroll down, and here let me show you the result and all based on this particular query. So it's going to be start from here. See guys, document. This is the first list. It's going from here to where? Here to uh how many document? Let me check. Document or page content. This is my first one. Here is my second document. Okay, here is my third document. Now let's see the fourth one and the fifth one. Right, sixth. Okay, here is what? Here is my seventh, eight, nine, 10, and 11, 12, 13. So I think in total, maybe I missed something. I think in total there should be 16 document. So based on this particular one, I think three or four I have defined. 16 document is there. You can count it, guys. Now this all the document we are getting based on this particular query. This one, right? And here we are re-ranking it also. We are re-ranking it also. So we are parsing the original query. Based on that, this is my generated query. Okay, and then after generating the query, this is the document which we are able to fetch. Now what I will do, I will pass this each and every detail to which one? To my main chain. Okay, so this was what? This was the like Rank Fusion chain. Okay, Rank Fusion chain which was there for generating the query. See here, Rank Fusion chain, this one. Now this Rank Fusion chain, whatever it will give it to me. Okay, this one, this is what? This is the rank document. Okay, rank document, because here we are using the reciprocal rank. Here see guys, this one, reciprocal rank. Now finally this content, this entire content which I am generating, okay, this particular content I am passing to my main model. Okay, this content I am passing to my main final model. So see, this is my prompt answer based on the like for the context. So this inside this context I will be keeping that this particular generated content, okay, rank content, and this is my question, whatever question basically I will be asking. Now here is my prompt template, and see, context. In the context, actually I am generating a context, this particular context, guys, please. Now guys, I can ask any sort of a question to my LLM. Okay, so here see what is happening. I'm taking this rank fusion chain, which is giving me a context, which I already clarify. Here is my question, which I'm getting on a runtime from template LLM and output parser. Now here is what? Here is my question. I'm saying, tell me about Singapore nightlife scene. So based on this one, see, first of all, it's going to fetch the four question. Okay, here is my four question. Let me show you. So likewise, you can check with the different questions and all, and you will be getting that. So see, there is a fourth question, and then it is going to fetch the content. Okay, based on this particular question. So it is fetching the content, and that content basically is passing to my model. And here is the final answer. And this final answer, guys, this one which you are getting now over here. Let me copy if I'm able to do it. It will be a more precise compared to the other answer, compared to the normal or the vanilla. Okay, vanilla rec pipeline. So I hope this part is clear to all of you. Now definitely you can check out, and you can test with the many more question and the different type of document and the data. So I hope you like this video. Now I will see you in the next video. Until, thank you, bye bye guys, take care.